Okay, so this is our third lesson on scale factor. Um, the last lesson kind of showed us how do we calculate scale factor and um, how do you find new sides. If you're given a scale factor, how do you take one shape and make it into a bigger shape? This one is going to be talking about the exact same things. There's no new math here really. It's just giving us word problems and situations in real life, and there are some important things to consider about that. So a quick review is that the scale factor is showing the relationship between two different objects, like the size of one compared to the other. So it always goes, like we can write it as a ratio, and it's always comparing like the new to the original. And it never goes original to new. We're always going to write it in that way first. So often I'll write it for short, like N to O, for new to original. When we're doing our math, the question often might tell us it in this form, but when we want to actually use our math, we're going to write it in fraction form. Okay, so the first number in a ratio is the one that's going to go on the top. So like the new goes on the top and the original goes on the bottom. And so I will often write it out in a problem for my formula. Say scale factor is equal to the new divided by the original. And the SF here is for scale factor. So an important note is that the original is always going to be the real life object. Okay, so what I mean by that is that if there's a situation where you have like a blueprint or a model of a real object, the real object, like a building or a train or whatever it is, the real life large scale version of that, that is your original one. If you, like, even if you were given the blueprint first and said, now go build this building, we are still going to call the blueprint the new object or the new thing, and the building the original. Okay, this kind of keeps keeps everything consistent, but in that kind of scenario, yeah, you just need to be aware of that original is going to be the real life. So on a blueprint, if it says like 1 to 50, that means the original, right, like new is this side and original is this side. We're saying that for every like 1 centimeter on the blueprint, that is 50 centimeters in real life. Okay, and all blueprints will keep it in the same order. That way, there's no blueprints. It's not like some blueprints are saying 1 to 50 and others are saying 51. No, it's always going to be this way. So here's our first example. So this says that someone built 2 versions of a table. They had one and they wanted to make a larger version. And it says, given the dimensions, like the measurements down below here, what is the scale factor that they used to make this new larger table? So it tells us in this case that the larger table is our new one and the smaller one is our original. Okay, sometimes the problem will just tell you. Now, if we want to find the scale factor, we're going to use the same equation we always use, which is scale factor is equal to a new side divided by original side. It's important that we pick a matching pair of sides. We can't just pick this side and call it good. Okay, they need to be talking about the same distance, or the same, like they need to be measuring the same part of the object. So this 25 inches is measuring its width, and this 20 inches is measuring its width. And so these two are a fair comparison. Okay, they're talking about the same pair of measurements. So to find the scale factor, then we're going to say the new, which is the new side is 25 inches. So 25 inches divided by our original side, which is 20 inches. And then what is our scale factor? So in our calculator, we'd say 25 divided by 20, which is going to give us, in decimal form, that is 1.25. Okay, 1.25. So we are taking all of these measurements then, and like all of our original measurements are being multiplied by 1.25 to get our new measurements. This is it then. This is the final answer for our question. And but sometimes you'll be then asked to use that scale factor that we found to find like a missing measurement. So we'd have to take a side and multiply by the scale factor and so on. All right, so the next example here at the bottom of the page says that a craft store uses small gift boxes to wrap purchases. They have a box that is 20 centimeters by 12 centimeters by 5 centimeters. Another box is larger by a scale factor of 1.3. What are the dimensions of the larger box? Okay, so I'm going to recommend drawing a picture for, honestly, for most questions, but it's not important that your picture looks good, but it does need to be clear to give you kind of a good idea of what we're talking about. So it says it's 20 centimeters by 12 by 5. It doesn't matter which one's which here. I'm going to call that one my 20, and I'll call this one my 12 centimeters, and this one my 5 centimeters. Okay, and so then I'll just draw my box according to that. Okay. Now I have a larger box that's bigger by a scale factor of 1.3. So I'm just going to, like, this isn't going to be like, to scale, but I'll just draw a larger box here just to help me kind of visualize what it is that we're doing. Okay, so now I have these two boxes, and it says, what are the dimensions of the larger box? So I need to find out those 3 dimensions. If it's getting bigger by a scale factor of 1.3, that means all these numbers are going to be multiplied by 1.3 for the larger box. So I'd say 20 times 1.3 to get this one, which would then be 26 centimeters. Okay. This one, 5 times 1.3. All right, so I jumped ahead a little bit there, but I said 20 times 1.3 is 26 centimeters. 5 centimeters times 1.3 times my scale factor is 6.5. And 12 centimeters times 1.3 would give me 15.6. Okay, so the new dimensions of this larger box are then these 3 measurements. They're all 1.3 times bigger. All right, now this question is where people are going to start to get confused. Okay, the first 2 are fairly straightforward. This one, first off, gives us the scale factor as a ratio, and then it also is talking about that kind of blueprint and real life situation that people can get confused. So let's remember to start that when we have a ratio, okay, think no, okay, NO, new to original. So this is my new is 1, and my original is 40. And what I talked about at the beginning is that the original is always your real life version. So in this case, our new is our blueprint, okay, our scale drawing or our blueprint. I'll call this one drawing. Okay. And if we're not going to want to keep this in ratio form, we want to put this in fraction form. So, okay, let's read the question and then I'll do the math from there. So it says, Xavier is building a staircase using scale drawings. On the drawing, the height of the stair is 0.5 centimeters and the depth is 0.9. Xavier will use a scale factor of 1 to 40 to build the stairs. Calculate the height and depth of the stairs he will build. So if we want to find out what's the new measurements, we need to times our measurements by the scale factor. So, and actually, well, we'll get there. First, let's just find out the scale factor. Okay, so the scale factor here then is scale factor is equal to the new divided by the original. Okay, so we said that the new was 1. Okay, the new is that one, and the original is 40. Okay, so all right, so there's 2 kind of ways we could go about this. Okay, so if we write this in fraction form, we're saying scale factor is 1 to 40. Our original is going to be multiplied by 0.025. So something very like a very small number is going to get very small to get our new. But the problem with this is that in all of our cases, like, okay, let me give like a tiny version of a staircase here. And here's the real life big version. Okay. Now, this one is our original, and this one is our new. So normally what we're doing is that we've been giving the measurements of the original, and we're going to multiply by the scale factor to get the new. That's why we're going this way. Okay, we have these measurements, and we're going to get our new thing. But what we have here is that we have the measurements of this one. So, this is the one that's like 0.5 and 0.9. Okay, and we're trying to go this way. So in this case, we're not going to be multiplying by the scale factor, we're going to be dividing. So, I mean, let's do that first, and then I'll kind of show you, maybe a simpler way to think about this and how you can kind of be checking your work. Okay, so this one is our drawing. This one is our real life version. we know that the original version is going to be bigger than the drawing. So if we had gotten confused and said we're going to be we're going to multiply by our scale factor here because we had these backwards. We thought this was the original, this was a new whatever. What we would get is we would get an even smaller number. I'm just going to make something up, but let's say it'd be like 0.003 or something. Here we're going to get an even smaller number, and that clearly does not make sense. If we are going the other direction, if we divide by this number instead, our number is going to get much bigger. So we're going to say 0.9 divided by this number and 0.5 divided by this number. All right, so that was the like kind of mathy way to figure that out. It's like taking this and dividing it by 0.025. So 0.9 divided by 0.25 is 36, and 0.5 divided by this is 20 here. So the other way that we could have done this, and this is like a much more straightforward way of doing it, is thinking that if this is my drawing and this is my real life version, my real life version is going to be 40 times bigger. Okay, my real life version is going to be 40 times bigger than my drawing, 1 to 40. So I could just take my drawing and times it by 40, and that would give me my correct answer. If I took 0.9 and times it by 40, it would give me this exact same thing, 36. If I took 0.5 and times it by 40, it would give me the exact same thing here of 20. So you can either go the route of finding your scale factor and then knowing that if you're going from your original to your new, you're going to multiply by your scale factor. Or, but in this case, we are going from our new to our original. We had our new measurements, we're going to our original, so in that case, we need to divide. So you can either find your scale factor, kind of get into this decimal form, and then figure out if you're multiplying or dividing. Or if you were looking at this and you have a good understanding of what this number means, it means your drawing is going to be 1 and your real life is going to be 40 times bigger than that. And so you could multiply by 40 here. Either way is going to get you the right answer. All right, here comes our last example. All right, so this question is kind of like the two-part one that I kind of talked about a little bit earlier, where it's saying this person made a kite with the dimensions shown below, and then they decided it would work better if it were bigger. So they made a new kite, and the new tail length had a length of 49 centimeters. So what scale factor did they use, and what were the kite's other dimensions? What were the other measurements? So it gives us, this is telling us that this here is our original. Okay, that's our original kite, and we're going to do a new one, and the new measurements for the tail was 40. We'll use red for the new one. Okay, the new measurements for the tail was 49 centimeters. So it says, what's the scale factor first of all? So the scale factor is the new side divided by the original side. So scale factor is, our new side is 49, our original is 28. 49 divided by 28. Our scale factor then would be 1.75. So now we have that. Okay, that's the first part of our question. We found our scale factor. Now we want to know what are the new measurements. So to find the new measurements, we just need to take all of our original measurements and multiply it by this scale factor, 0.75. You remember I said when we're going from our original, when we're going to our original to the new, taking from the original, going to the new, that's when we're multiplying. If we had taken the new one, like the big one first, and wanted to go backwards, that's when we would have to divide. Okay? But in this case, this is kind of a straightforward example, taking our original thing, making a new thing, so we're multiplying by a scale factor. So we're just going to say 20 times 1.75. We're going to say 8 times 1.75 to get the new one for that. And then 40 times 1.75. And that will give us our new measurements. All right, so if you put that all into your calculator, these are the answers that you should get. 20 times 1.75 is 35. 8 times our scale factor is 14. And 40 times our scale factor is 70. Okay. So that's that should be enough to get you through the practice problems in here. It's easy to get a couple of different things backwards in these. So I would definitely encourage you to, one, be drawing pictures, and then two, really be thinking about, does this make sense? Okay, is my answer supposed to be bigger, and is it bigger, right? Or if I was expecting my answer to get bigger, but my numbers are now smaller, then I've probably like divided instead of multiplied or something like that somewhere, or put my fraction upside down, things like that. So be careful with it. And yeah, be sure to be like really try to think about what is that real life context, what's really going on in this problem, and does this make sense? Okay. Good luck.